Hey everyone. Thank you for watching our presentation. This is for our group presentation for homework number 2. Together with my teammates, my name is Aiko Tan. We have Saadman Khondaker and Chi Chan. And for this particular assignment, we have a particular case scenario, specifically a university, XYZ University, where we have an admissions department facing some challenges in the website. So the task and the objective of this project is to design a proof of concept web application hosted with the AWS website addressing the issues mentioned in the given problem. So with this, with respect to the time allocated with the video presentation, we're not gonna go deep dive into the report. All of the information is well written in the report, and you are free to access that on our separate documentation. We'll go deep dive particularly now into the section of how we designed the architecture. And for that, I'm going to be passing it on to my teammate, Sadman.
Thanks, Iko. Let me walk you through our system architecture and capabilities and next step. System overview. Our system follows a modern three-tier architecture. On the front end, we have an HTML and JavaScript interface that uses Ajax for seamless user interaction, no page reload required. The backend is powered by the Node.js and the Express.js provided robust API layer running on the AWS EC2. For data persistence, we are using MySQL hosted on Amazon RDS, ensuring the reliable and scalable data storage. The core functionality centers around the full proof operation create, read, update, and delete, allows administrator to efficiently manage all student records. Now, I'm talking about the current architecture. I'm pleased to report that we've already implemented the production-ready infrastructure. We have an application load balancer distributing traffic across our EC2 instances with the auto scaling group managing resources across multiple availability zone. Our instances are properly secured through configured security groups, and we are connected to AWS RDS MySQL for our database layer. This setup ensures both high availability and automatic scaling based on demand. The API endpoints, our RESTful API provides us 4 essential endpoints: the post/student as new student records, get/students retrieves all the students' data, and put/students with an ID update existing records, and delete/students with the ID removes the records from the system. All endpoints are accessible through our load balancer, ensuring consistent performance and reliability. Current production features, we have successfully implemented several critical production features. Our application load balancer and auto scaling groups are operational, providing automatic traffic distribution and resource management across multiple availability zones. Our VPC configured with the security groups ensures the proper security isolation. Looking ahead, we are planning to add AWS WF for enhanced security protection, RDS multiple AZ, and high availability and call font with S3 for optimized static asset delivery. For security best practice, security paramount is our design. We are implementing AWS Security Manager for credential management and session manager for security administrator access to eliminating the needs of SSH keys. Current limitation, I want to be transparent about the challenges we're addressing. We have observed occasionally service responsiveness issues where the Express.js servers becomes unresponsive, causes slow processing timeout errors. Currently, we resolve by restarting the server process, which restores to normal operation. However, we actively investigated the root causes, and which may be related to the resource exertion and network instability. So I'll move to Lynn for next slide.
Thanks, Saadman. So next, I will explain the reason why we choose this specific design, the architecture. So let me share my screen first for easier to follow. So we have 8 points here that I show, which is the 7 main reasons why do we choose this specific design. So firstly, the functional design. Our application is built with Node.js, which have to handle API requests more efficiently. So for database, we use Aurora or RDS for proper indexing or query optimization. And CloudFront supports static access from edge location, would reduce latency for user in different areas and improve front-end performance. And also we use database connection pooling to avoid overhead associated with frequently opening and closing connections. With all of this combination, it will ensure that viewing, adding, deleting and changing student records will happen quickly and without any delays, even as the number of users grows. The second reason is about load balancing. We use an application load balancers to distribute user traffic across multiple instances. So for example, if one instance fails, the traffic will be redirected automatically to other instances to prevent the server from being overwhelmed and guarantee a smoother experience for all users. The next reason is it's easier to scale. For auto-scaling group, it will automatically launch new instances when CPU latency or request count increase. It allows more simultaneous read requests without overloading the primary database. It also have high availability. For EC2 instances, it runs in multiple available zones. So if one zone fails, it will remain accessible and the database will be configured in Aurora multi-availability zones. So it will switch to the backup replica in the case of failure. So it will make sure it minimizes the downtime and keep the system strong against failures. And the reason about security, because we keep our database in the private subnet with no public access, so we add protection against the attack. And the session manager will have to replace the direct SSH, reducing risk, and security is built in at every level. And the database isolation function is also have to accept requests only from the app servers. It would never expose to the internet, with keeping the data safe. It's also very cost optimization because we start with the free tier servers in testing, and in production, we use the right size servers for auto scaling. So we only pay what we need. And it's also very high performance. CloudFront caching makes content faster. And for user everywhere, load balancer reduce optimized query and smart VPC design cut down response time. So in summary, our design is fast, scalable, secure, and cost efficient. So next we'll come to Aiko. We talk more about our architectural diagram.
Thank you so much, Shi, and thank you, Saadman, as well. So what both my team members have mentioned is essentially pretty much how we made sure that the output of our report for this assignment is something that is doable, scalable, and that all of the mentioned sections are very important in terms of achieving the goal of the situation. So let me also quickly share my screen, and I'm not going to take so much of a time. You would be able to have access to our page where you will be able to check out on your separate time. However, I'll just do a quick demonstration of the page. So let me quickly share my screen as well. So what both of my teammates have mentioned is essentially our diagram, where it's a very easy, like user-friendly website. Not much like differences, like in terms of like the overall architecture is very straightforward and very simple. Of course, this is for the purpose of the assignment particularly, and given that we are using a free tier for this demonstration, if the client in the future would actually like to further expand, and of course more features in AWS would be available. All right, so to quickly show you, this is pretty much the website in achieving the 4 goals set in the assignment, where we have inserting the student information. This is the default page or your landing page. The moment that you open the URL, you will be landing on the insert student information page, which is you just pretty much put your information right here, submit, and you would be able to include the information of the student into the database itself. Of course, again, in achieving the set objectives, you would be able to insert the students, view student information, delete student, which is pretty much just select the student ID from your list, and then you'll be able to delete from here as well. And then if there would be any errors, of course, there would be an option for you to edit student as well. Again, similar process to deleting. You just have to select the student ID and then make your edits and then click on edit student. Again, to the point of my teammates, we've designed the page to make it user-friendly. And again, you'll be able to gain access to this link as well. So if you want to suspect and check it out later on, feel free to do so. And that pretty much brings us to the end of our presentation. However, again, in summary, we wanted to ultimately give you a takeaway where this prototype essentially just demonstrates how the university can modernize, the system, cloud, improving both efficiency and overall student experience. And of course, with the limitations that we have highlighted in this presentation, further exploration and expansion is available, mainly with purchases and some more fees depending on how we want to extend the need for improving the website. So if you would have any questions, don't hesitate to reach out to us. Thank you for your time and have a great day.